My interest started in college in thermodynamics course that I took junior year. The course covered different ways that energy is produced and transferred, and it's kind of one of those sciences that applies to almost everything. It's hard to find an aspect of life that thermodynamics doesn't apply to. Your home, the way you get around, the food that we eat, everything. And so that interest in the thermal science was just fascinating to me. And from there, I developed a more specific interest in refrigeration systems, specifically at low temperature, cryogenic refrigeration systems. When I got into the professional working world, I transitioned to a more conventional or more everyday technology of HVAC and refrigeration equipment, things that more people are familiar with on an everyday basis. NIST has several great programs for students, ranging from high school to college students. The SHIP program, Summer High School Internship program, is a way for high school students to get involved with NIST. Typically it's a several month time frame in the summer where you have a chance to work closely with researchers and other people within a group of your interest. College has another program. It's called the SURF program, Summer Undergraduate Research Fellowship, and students from colleges around the country can apply for positions at NIST, working in areas that they're interested in. Then there's also longer appointments for internships and co-ops. And those can range from 6 months to a year. I have a PhD in mechanical engineering. To get there, I completed a master's degree in mechanical engineering. And people in my position tend to have PhDs in either mechanical or chemical engineering. From a more broader perspective, people in the HVAC and refrigeration equipment group, and also the larger group of people, my division that I'm involved with, which is called the Energy and Environment Division. There's people with PhDs, people with master's degrees, and they tend to head the research efforts. Tends to be about 2/3 PhDs and 1/3 masters. And then there's also a number of technicians who do a lot of the hands-on work of building the experimental apparatuses and coordinating construction efforts and maintaining facilities. And they typically have an education that ranges from technical college up through bachelor's degree. I would almost say they're the most diverse group within our division because their backgrounds are so varied. Some people come from the working world, where they're doing maintenance of HVAC systems. We have an airplane mechanic. There's machinists, an electrician, a car mechanic. So they really come from a broad background. What is my typical day? Is a question of at what point in the project am I at. I spend the most time working with designing and planning and executing experimental research. The process, of course, varies from project to project, but it seems that the cycle of a research project tends to be about a year and a half to 2 years from concept to finishing of construction and starting to actually take data. As a principal investigator, I need to find out what do I not know and who knows how to solve that problem. For work, I travel around, and whenever I fly anywhere, I notice that, every building has HVAC equipment, every city has lots of buildings, and every state has lots of cities, and it just expands, and you just think of, you know, the impact of your work can be huge. And so I think that's an exciting thing in terms of personal fulfillment about the job. I think also on a more narrow level, solving problems is, I mean, that's what engineers do. We love to solve problems, and I solve problems every day. That's the thing, and that's exciting to me.